Hi, this is Minis Joannides, Chief Medical Director at Optimum Re, and this is the Optimum Academy Cholesterol 101, video number 1, cholesterol and its delivery vehicle. So let's get started. So you've probably seen diners, drive-ins, and dives on TV and all the fatty foods that might be eaten on that program. Nice greasy burger or maybe some poutine with fatty gravy and chunks of cheese. So these are both sources for high amounts of animal fat and put the body at risk due to all the inflammation that comes secondary from eating things like this. So I called it diners, drive-ins, and defibrillators. So what is cholesterol? So it's a waxy fat-like substance. It's found in all cells of your body. It isn't all bad. Actually, it's essential for your body to stabilize the cell membranes in the cells of your body. But your body makes all the cholesterol that it needs for the cell membranes. So any cholesterol that we eat from animal sources, such as egg yolks, meat, butter, cheese, things like that, they elevate our cholesterol levels. And when cholesterol levels are elevated, it becomes pro-inflammatory. So the entire body is at risk due to the inflammation of high cholesterol levels. And subsequently, atherosclerosis can develop, or plaque in your arteries, which is a negative feature of high cholesterol levels. So abnormal lipid levels can adversely affect many aspects of our health, including even the viability of human ovum fertilization. So it has a widespread impact in our life. So let's break up the word. What does cholesterol actually mean? So C-H-O-L-E, chole, means bile in Greek, and S-T-E-R from Greek stereos means solid. So we have a bile solid, and then the O-L part means that this is an alcohol, because anything that ends in OL is an alcohol. So it's a combination of 3 parts. And it was discovered in the 1700s when it was noted in bile-related substances. So cholesterol is a hydrophobic fat, meaning that it hates water. At least one end of it does. And that's the chole part, the C-H-O-L-E. That we said it was associated with bile. That part of the molecule hates water. The middle part, or the ster part, is ster for solid, and then the OL part, or the alcohol part, actually likes water. So we have a molecule with one end of it hates water and one end of it likes water. So in our bodies, if we have a fatty substance like cholesterol, how do we get it to move around in the blood, which is actually water-based? And I have a couple of bottles of salad dressing up at the right top, and you can see what happens to salad dressing when it sits in the refrigerator. It separates. The fat goes to the top, the water-based substances go to the bottom. So you have to keep shaking it up when you want to put salad dressing on your salad. Otherwise, if you just pour the top part out, you're just going to get the oil part. So in our bodies, we can't shake up our bodies to keep the fats and the water parts mixed. So we need a way to deliver cholesterol around the body. We don't have FedEx or UPS to do it for us. We can't call Wishbone to see how we could solve a salad dressing problem in our body, right? So what we have is something called lipoproteins, which I have in red at the bottom, the last bullet. And that's how we deliver cholesterol around in the body. So today we're going to be talking about not only cholesterol, but lipoproteins. So here's my course on organic chemistry today. Organic chemistry is not organic farming. That's different. Organic chemistry means there are carbon atoms in the molecules we're going to talk about. So when you have carbon atoms, that's organic chemistry, and that's the end of the course. So that was a brief course. Now you know about organic chemistry. So let's look at our cholesterol molecule again. So the chole part hates water. That's where that green circle is. So that's 8 carbon atoms and 17 hydrogen atoms. That's the chole part that hates water. The middle part, the STER equals the solid, means solid. That's the main part of the cholesterol molecule. And that has a whole bunch of carbon atoms. All those C's are carbon atoms and all those H's are hydrogen atoms. And then in the gold circle is the OH, or the oxygen and hydrogen. That's the alcohol part, and that likes water. So we have part that hates water, part that likes water, and then in the middle, that ster part, actually that's where the word steroid comes from, because a lot of steroids have that same structure that you see there in the big red circle. So we have the ster part, and you can see all the different kinds of steroids that come from that ster part, like cortisol, progesterone, testosterone, estradiol, aldosterone. They all have that same ster part, just like cholesterol has. So here's what we're going to do. We're going to tip this molecule clockwise by 90 degrees. So we're just going to tilt it so that the green circle's at the bottom and the gold or yellow circles at the top. So everybody with me? We're going to tip it 90 degrees. So I put 3 molecules here now. So we have the gold, or the OH part, at the top of these 3 molecules, and we have the green, the part that hates water, at the bottom. And you can see at the top the father with his kids. You know, that family likes water, so we're going to call them hydrophilic. They like being in the water, whereas at the bottom, the green circles, that kid doesn't seem like he's too happy, so he's anti-water or hydrophobic, and so that's all those green circles are at the bottom. So we have the hydrophilic at the top and the hydrophobic at the bottom. I hope everybody's with me on this. So what we're actually going to do now is put 2 layers together. We're going to use the layer we just made, and at the top is the side that likes water. In the middle, we're going to put the ends that hate water, and then at the bottom, that end, which is the gold circles, likes water. So in the middle is the part that hates water, so we kind of tuck that in the middle, and then on both sides of this 2 layers are the parts of cholesterol that likes water. So we kind of made a sandwich here of water liking ends on each end, and in the middle the part that hates water. And a big fancy word for this, when you have both hydrophilic and hydrophobic regions, is amphipathic. So let's build a lipoprotein now. We made this 2-layer of cholesterol, right? So you can see the red arrow, it kind of makes a sandwich. And then what happens is that sandwich actually develops into a sphere. And we put all the fatty substances in the middle of the sphere, and we keep the outside covered with the part that likes water. So that's how the lipoproteins can go through the blood, which is water-based. You can see far over to the right, ice cream sandwich kind of morphs into a ice cream ball with the water-loving part on the outside and the fatty part, which hates water, on the inside. So we go through this process of making this 2-layer sandwich into a ball, and that's how we make lipoproteins like HDL, which is high-density lipoprotein, which you've heard about, and that's the good cholesterol. So one other feature is that I mentioned that cholesterol is in the human cell membranes, and it works the same way as that 2 layers that we just talked about. The water-loving part on the outside of the cell membrane, and on the inside, the fatty part, which doesn't like water. The cell membranes have this 2 layers, which allows selective permeability into the cell. So not everything gets into the cell. It kind of is like a gatekeeper to allow certain things into the cells. And it's kind of like an M&M that has gooey stuff in the middle. The fatty part is in the middle, and then the water-loving part. It covers the outside. So kind of like when you cut open a golf ball, you can see that the outside cover kind of protects the golf ball, and the inside cover is that spongy material that it provides the certain density and compaction when you hit a golf ball to make it go further. And just like we talked about the outside of the cholesterol, the lipoprotein for cholesterol is it can move around in water, just kind of like golf balls. They can move around in water too, and that's probably where all my golf balls are, at the bottom of whatever water that this is a picture of. So when we talk about lipoproteins, we usually talk about three main ones, which are HDL, or high density lipoprotein, LDL, low density lipoprotein, and VLDL, very low density lipoprotein. So HDL, the high density lipoprotein, that's the good cholesterol because it helps your body get rid of cholesterol. The LDL stands for low density lipoprotein. That's the bad cholesterol. And that actually transports cholesterol to the tissues, and that's how buildup of plaque can happen in your arteries, whereas the HDL is actually the vacuum cleaner that helps clean up cholesterol. And then VLDL carries triglycerides around in the body. But mainly today we're going to talk about HDL and LDL. So when we talk about lipoproteins, we're going to talk about the good, the bad, and the very bad. HDL is the good cholesterol, and that has what's called a lipoprotein called ApoA, or apolipoprotein A. That's good. That's that red band that wraps around HDL. The LDL has ApoB. That's that blue band that wraps around LDL. So we have on HDL, Apo capital A, and on LDL, we have Apo capital B. Now at the bottom, you can see I have circled in red, there's another lipoprotein, which actually kind of looks like they took an LDL and then they stuck some beads on the side of it, like I have circled in red. And that's apo(a) attached to the ApoB on an LDL molecule. So that's what's the really bad kind of lipoprotein, and that's called lipoprotein a. So the three types of lipoproteins we're talking about here are the HDL, the good cholesterol, LDL is the bad cholesterol, and lipoprotein a, in parentheses, is the really bad one. And that's an LDL with this funny looking bead structure called apo(a). So it gets confusing because we have apo(A) is good and apo(a) is bad. And you can blame this fellow who named apo(a), and it had to do with the timing of when that was named. He was Norwegian, and he came up with this nomenclature back in the 1960s, but we're going to blame him for all the confusion that we have. And even when you look up apo(a) and apo(A) on things like Google or Perplexity or ChatGPT, the AI, generative AI, things like ChatGPT and Perplexity can get apo(a) and apo(A) confused. So you have to be on your toes whenever you're looking these things up, because even the generative AI helpers may get confused. So the protein in lipoprotein is called apolipoprotein, and that's why we call it apo(A), apo(B), and apo(a). So you got to know which apos you're talking about. By the way, apo(A) is genetically determined, so it doesn't vary according to our diet, whereas the other two vary depending on our diet and what medications we might take. ApoA is kind of independent, and it's based on our genetic factors, and it's difficult to make changes in the levels for those people that have an elevated level. So how do we make the protein and apolipoproteins? Well, all proteins are made out of the building blocks of amino acids, and so that's where the protein part of an apolipoprotein comes from. So just like you've heard of tryptophan when you eat turkey at Thanksgiving or holidays, tryptophan is an amino acid, and it's basically built out of an amino group and an acid group. And there's 20 different types of amino acids because where that R is attaching to the middle carbon atom, there's 20 different varieties of groups that can be stuck onto the amino and acid group, and that's how we make all 20 different amino acids. So the protein part of an apolipoprotein is built out of amino acids. So the bad cholesterol we talked about is LDL. The dash C just means cholesterol, so that's LDL cholesterol. And that's to the left. And you can see that that has that red strip on this particular picture, and that's the apo big B. And then to the right is the lipoprotein little a in parentheses, and that's an LDL molecule with the apo B, and then attached to it is the apo little a in parentheses, and it's those curly Q things that are attached on the side here, and we're going to talk a little bit more about those when we talk about lipoprotein little a. So here's kind of a different graphic, and you can see that lipoprotein little a in parentheses has the LDL molecule in the middle, and then around it is this apo little a in parentheses. And it's made of these things called KIV-1 through all the other numbers up to 10. So it's KIV1, KIV2, KIV3. And here's the important thing to note. Lipoprotein little a has different numbers of KIV-2 for each different person. Each person makes a different number of KIV2 copies. So in this case, if you look at those red circles, there's lots of them. Actually, that's a sign of a better lipoprotein little a. The fewer the number of KIV2, the worse the prognosis. So it's kind of inverse in your thinking. Actually, the smaller the number of KIV2s, the worse the outcome. And so what does the KIV actually stand for? So the K stands for the word Kringle. The IV is actually Roman numeral 4. And then the dash, and this in this case 2, shows which of the 10 Kringles they're referring to. So in this case, there's lots of Kringle 4s dash 2s that are on this particular type of lipoprotein little a. And cholesterol is not evil, but high lipoprotein little a is a killer. So that's why we're concerned about lipoprotein little a. And again, what is lipoprotein little a? It's an LDL molecule with all these Kringles stuck to the side. And here's just another representation of lipoprotein little a to the left with the Kringles or those beads attached, and an LDL molecule to the right. And you can see that lipoprotein little a is just a LDL molecule with these 10 different types of Kringles attached like beads. And you can see that they're enumerated KIV1, which is Kringle Roman numeral 4-1. Then these Kringle -2 repeats, and in this case there's 4 Kringle 2s. Then there's Kringle 3, 4, 5, 6, 7, 8, 9, 10. So those are all 10 different types of Kringles, and then it's attached to the LDL ApoB by a disulfide bond at about Kringle 9. And that completes our first talk, Cholesterol 101, talking about cholesterol and lipoproteins. Stay tuned for our next video on cholesterol.